Hi, my name is Geoff Cast. I'm the CEO and founder of Wilder Sensing. We set up Wilder Sensing to understand how biodiversity is changing across the site, across the landscape over the medium and long term. My background, I was a technologist, software solution engineer, software engineer, a geologist, ran sales and marketing in some major companies like IBM and Oracle. And outside of work, I was a bird ringer, bird bander, trustee of wildlife charities. Unless we can understand the impact we're having on sites, both for good and for bad, we don't really understand what good practice is and what not so good practice is to how to improve biodiversity. So I'm going to be talking a little bit about how we do this at Wilder Sensing. How does it work? I'm going to use a case study from in the UK where we were on the BBC for a program. We got 2 million viewers, and we look at the strengths and weaknesses of different methods. Because like all methods, they've got strengths and weaknesses, and bioacoustics is got its weaknesses as well, and draw some conclusions. So how do we use bioacoustics data to assess biodiversity at scale? Doing it today, there are some issues associated with the cost of doing long-term monitoring, the time it takes to do it, and the consistency of the bias in doing field-based surveys, with different ecologists or different birders or whatever having different levels of skill. It's very hard to get good time series data. So we need a solution if we're going to start monitoring this on a much more granular level. A solution had to be low cost, so it was easy to deploy within constrained budgets. We had to be able to scale this globally. Can we scale it globally? And commercially, does it work? The low cost of processing what's become vast quantities of audio. Are the results auditable? Can someone go back and say, yep, that particular species called at that point in time because it was a particularly important indicator of a rare endangered species or whatever? And can the results, how do we present the results in a way which can drive insights to say, well, we're getting some types of birds or whatever appearing on the site or disappearing from a site, or the species mix is changing, or how the species are distributed across the site can give you enormous insights as to how you could manage that site. And are the results accessible? So can anyone use this application? We are a software as a service platform. And can they get the results out of it in a way which doesn't require Python or R skills? That might be fine for a PhD student, but not fine for a field-based ecologist or a citizen scientist or a landowner. And whatever approach we took to do this had to be underpinned by great science. The results had to be accurate, as accurate as you can get. And the only solution to all those requirements was bioacoustics. It fits all those criteria. Other solutions like eDNA or whatever don't fit so many of those categories. But we had to do more than just use bioacoustics. We had to come up with a solution which was scalable and engaging. So that's why we built Wilder Sensing. We spent a year trialing it in 2023, and now we've got sites that have been running for 2 years, generating some very detailed large data sets, which I'll come on to. So how can we measure biodiversity? How do we do that using sound? And this is a method most people on this call will be familiar with. You put your recorder out, record. In our case, we often recommend recording 24/7. That's clearly problematic if you're in remote sites, so you might have to sample. Files get uploaded through a file manager type interface. In the background, we run the machine learning, the AI. We work a lot with Cornell or with BirdNet in this particular instance. And then each 3-second clip gets assigned a couple of data points. One is the probability of this occurring in that location and the confidence of that bird or whatever is being identified. Filters probably needs a bit of a discussion another time, but it's really important that they use the right filters. And then once you get the results, can you go back and validate that it was in fact these particular species of birds? So from our experience here, one of these great wildlife acoustic recorders working 24/7 will generate about 1.3 terabytes. And on a site, we've got sites with 20 plus recorders generating obviously vast quantities of data. And that's one of the things we have to consider is how do we accommodate terabytes and terabytes and terabytes of audio in a way which was scalable. In many cases, some of our customers don't have that capacity or the skills or whatever to be able to share these data, these vast amounts of audio. And A recorder will generate about 250,000 species level records a year. Obviously, it depends on the habitat and time of year, but some sites are generating over 5 million species level records, which allows us to start asking very, very different questions that we couldn't even think of before. I'll be going through a case study to show that. So the case study is one from this spring. It's based on a site in the south of England, a place called Poole Harbour. It's a very well-known RSPB site. RSPB are the main bird life entity in the UK. And it was on a TV programme called Spring Watch, which is a live programme broadcast for 3 weeks every evening. If you can, there's a link on the screen, episode 11. If you're outside the UK, you may not be able to get access to it because of being able to share stuff outside the UK. If you want, I can send you a short copy if you're interested. But suffice it to say, the researchers went through a lot of data, and they were really happy with the results. We put out 6 recorders, courtesy of Wildlife Acoustics. They were there for 6 weeks. We recorded about 7,000 hours of audio. When we processed it, we got about 430,000 records at species level from about 89 species, and including a new species for the site. Now, bear in mind, this is a site which is very well visited by lots of good birders. Spoiler alert, we found a bird called a wood warbler, which doesn't nest on site. It was just a migrant passing through. But it was quite a bit of a coup. The researchers got really excited because it's something they hadn't seen before. So the results, the results all go into a data lake with lots of analytic tools on top, and this is just some screen grabs from a few of these things. But how do we define what quality is? Data quality is really important. As I mentioned, we applied two data points to each record, the probability of this bird occurring in this location, and the confidence of that species being identified. So typically we would recommend having a detection confidence of about 85%, and a location probability of 1%. If you push it much lower than that, you'll start to bring in some spurious species which are very unlikely to be present on site. Obviously, the greater your detection confidence, the lower the number of records that you use. And you just use this on a slider bar on our website. So it's where you can start to control the data. You can also go through and then validate some of the species that you're particularly concerned about. And there are many, many ways we represent the data. So at the bottom of this screen here, we've got species location preference. From these 6 recorders we had on site, this site had quite a diverse set of habitats. So you're seeing very different call rates occurring in different habitats. But what's interesting on sites where we have a fairly even habitat, where you might think, the birds that don't have a strong preference to a certain habitat, like wading birds or water birds or whatever, but some of the passerines you think might be evenly distributed, but they're not. We find time and time again, certain parts of a site, you find 90% or even 95% of a particular species, and that's where they stay over the season. They might migrate or whatever afterwards, but and then next year they come back and you see this when you're out birding. You'll find you know where the good spots are in your patch. I don't know why they do that, but if in terms of a conservation of a large site, perhaps those sites need to be protected to maintain those populations of those birds, some of which might be critically endangered or whatever. So it gives you a lot of insight into that. And you can see that at the bottom of this screen, the Eurasian bullfinch, they're pretty much in 3 of the 6 sites, and you see that time and time again with every other species. Now, lots of other ways of looking at the data. So bear in mind, this data set, we had 430,000 records. So things like species richness. Now, species richness is a good indicator of obviously biodiversity. And because we have these records generated every 3 seconds, over time we can start to get some really good trends. So this particular graph, species richness on the slide here, on 1, the location was next to a sort of brackish lake. It was called a clay pit. It was where clay literally been dug out for building or whatever, and next to Poole Harbour. So you had a lot of open water with a good area for wading birds, and then just behind it we had some mature oak. So we're picking up species from different habitat types. but consistently this gave us by far the greatest species richness. Contrasting that with ARN5, which is the one at the bottom of this screen, of this graph. So ARN5 was in a plantation of coniferous forest, man-made planted coniferous forest, very dark, dank, be used for timber or whatever, or pulp. And the only reason this wasn't even lower was that there was actually a bomb crater from the Second World War right next to where they put the recorder, so it picked up some of the water birds as well. If it hadn't been for that, the species richness would have been even lower. But the ones that we were finding in there were typical dense woodland species, like in the UK, like we get goshawk or firecrest or tree creeper or whatever. Now, over time, depending on if you're managing a site, you may be expecting species richness to increase. It'll certainly change if you're managing a habitat differently. And one way you can start to measure the change is looking at a specific index. Now, in the bottom right here, we have what's called Farmland Bird Index. In the UK, this is a nationally recognised index for, I think it's 16, 17 species of birds that are heavily dependent on farmland. And these birds have been down by about 90% over the last 40 or 50 years because of industrialisation of farming, removal of hedges, that's this kind of stuff. So because we've got the data, we can start to report on this. So we can report every day, which is far too low level of granularity, but every week, every month, and over the course of years, saying, well, of these 17 species, we've got 10 on this site. What do we do? What interventions do we need to make to get us up to 11, 12, 13 species? Some of which should be relatively easy if you're doing winter feeding in January and February in the Northern Hemisphere, to attract some of these seed-eating birds that they're not present because there's literally nothing for them to eat because it's been so well farmed. So again, lots of different ways of analysing the data. The other thing I wanted to move on to, how to compare this to doing site surveys. Now, obviously, historically, physical site surveys have been the standard, and long should it stay that way. But what we're doing with this approach is complementing site surveys with a whole new set of insights. Now, we're trying to mitigate some of the issues with site surveys. I mean, one of the issues I mentioned earlier is recorder bias. If you get different ecologists, birders, whatever, going on site with different levels of skill, they'll get different results. So it makes time series data quite difficult to use. These recorders are working 24/7, so we get really accurate time series data. The biggest problem we found actually is batteries running out, or in some cases, lots of volunteers going out and managing these recorders, visiting every 2, 3, 4 weeks, going on holiday or getting ill, and we get gaps in the data. So it's a really important thing to think about when you're doing this to make sure you can remove that variability. The cost of a site visit for an ecologist or whatever can be quite significant. In many cases, we have some ecological consulting firms using this, and rather than doing 6 site visits for a project, they'll do 3 site visits and leave the recorders out. So they get the right balance between ground truthing what they're seeing but getting long-term accurate data, which they can then validate subsequently. Say we can run 24/7. Access restrictions can be an important consideration. If it's a very difficult physical environment, if you're in swamp or reed beds, some sites, certainly in the UK, you're not allowed to visit whatsoever because you've got some really rare breeding birds. You can't really visit from, say, January through to August. And so getting recorders out there can be quite challenging. Other sites, like adjacent to railway lines, can be challenging because of all the permits required. And disturbance can be another factor as well. We see some really good research done on some scarce species, some quite endangered species like the capercaillie up in Scotland, where someone being on site to look at the lecking behaviour that they enable the males come together and display. Someone being within 100 or 200 metres will disturb that lecking behaviour, and that could impact breeding productivity. And the evidence base, having good audio recording can really help make the case of a species being present or not. And we've got some good example. If you go on our blog, Aurora, one of the PhD students we supported, working with their researchers in the Amazonian wood in Peru, found a species that hadn't been recorded there ever within about 100 kilometers, and they could validate by the call. Having said that, site surveys can still be very important. Not everything makes a sound for obvious reasons. So you can make visual identifications. We can't really make a meaningful argument for measuring abundance of a species at the moment just by using a simple 3-second sample. We can't tell you if it's one species made 100 calls or 100 individuals made a call each. Having said that, we're exploring approaches to triangulation to see if we can identify the direction, the distance, and the height of a call, and we've made some good success. Our CTO is a PhD physicist who is coming up with the algorithms and the models to do that. Obviously, some birds are much more vocal; their calls travel much further. Some species, while they do vocalize, they have a very short range in terms of picking them up. So, being on site, you'll find some of these things. And background noise can be a major problem. If you're getting lots of anthropomorphic noise, obviously they can cause problems with recording. But having said that, we're working on sites which are heavily industrialized. They've got trucks going past all the time, and we still make a pretty good species list, which is validated online, and we can tell by day and night comparisons. So finally, I just want to go through some of the considerations to think about. What we do is probability based. If you look at the graph, the diagram earlier, we talked about things being 80 or 90 or 85% probable. Well, by definition, some of them will be wrong. Obviously, you want to increase the quality of your data as far as you can. And if you get more and more data, if you've only got 200,000 or 300,000 species left when you're at 95% probability, that's way in excess of anything you'll have had before. Accuracy of the models. Some species are hard to differentiate. Their calls can be very, very similar. The quality of the audio, that's why we like working with Wildlife Acoustics, because their stuff is good equipment. The other thing which is an important consideration is managing your data. I mentioned earlier that we get customers who've got hundreds of thousands of hours of audio, and that can be a real challenge for people to organize on their own servers or an infrastructure. We use AWS in the background, and we can archive it and keep it safe and all that kind of stuff. There's a hygiene factor. Getting a survey design right and managing your recorders have a management plan for that is really important to make sure you're trying to minimize the gaps in recording. Abundance, subject to a longer conversation, but we starting to explore triangulation as a way of identifying individuals. And many organizations also want to start mixing and matching with other data set, because things like climate data can be really important to understand the impact on species presence or even abundance, certainly. So getting good time series data from multiple sources can be really important. Making sure it's auditable. If you have to go back, if you're making a submission to a government or whatever, it needs to be needs to stand up to scrutiny. The costs, you start layering all these different data sets, the costs can start to stack up. Accuracy, different technologies have different levels of accuracy, but really understand when you combine these, is there new understanding created? More data doesn't equal more insight necessarily. It can create sort of paralysis by analysis. So what we've been trying to focus on is simplifying complexity. We're trying to make this thing scalable, accessible to anybody, and simple to use, but not simplistic. People still need to understand the limitations of what we're doing. And finally, it needs some interpretation. We get false positives, and someone who's knowledgeable of that site, that location, the biodiversity will look at it and go, that doesn't seem right. That species hasn't been recorded before, so it could be important, so we need to go and validate it. So being able to interpret this data is really important. With that, I'll stop. Any questions? There's my contact details. Thank you very much. Now we'll on to questions.
Thank you very much, Geoff. Wonderful presentation, and obviously you're moving away from the bat side of things. This is on birds, but I assume it can be applicable to many other things, and that I know that's what you're hoping for definitely in the future. We have loads of questions. You're getting lots of claps as well, so whether you can see
Thank you
those.
very much.
So first question is, what is the benefit of monitoring 24/7 versus like schedule recordings, and how do you decide which method is appropriate?
That's a very good question. There's a lot of different reasons. It comes back to what's the exam question you're trying to answer. What's the purpose of the project on the site, and also the constraints on the site. I mean, we have customers who just record around dawn and dusk for birds. There's no simple answer to this. It really comes back to your survey design of what's appropriate. We're actually, I mean, seeing your thunder here, Paul's going to do a session on our webinar in 2 or 3 weeks' time about exactly this issue. How do you design your sampling methodology? So yeah, it needs a bit of thought. I mean, the way you set it up is going to depend on your site conditions and your ability to access the site, like those sorts of things. Probably subject to a much longer discussion, which we'll have on the 26th, hopefully. Paul.
Yeah, Geoff is running his own webinar. So if you look at the Wilder Sensing website, you will be able to have a look at that. And someone has actually requested, I mean, when we finish the Q&A, if you put your contact details in the chat as well, that would be quite good, because I think people wouldn't mind that. So what filters are used to get the performance? So do you use any filters for your sort of, in effect, AI analysis?
Well, filters can be many different things at different parts of the kind of process. The filters I was specifically referring to in that slide, which is one of the important ones, is the way that the AI works. It matches, say, a 3-second clip against any species in the library, irrespective of the location. So it'll if it's a closer match to an Amazonian motmot, even though you're based in the UK, it'll generate a record. So you have to apply some filter to it to say, well, we only want species that are likely to occur within the area. And there's a number of ways of doing that. You could use reference databases like eBird. You provide the latitude, the longitude, and the week of the year to try and get seasonality into that filtering. Or you can just use a species list. Some projects we use the species list for the UK or for England, and just filter on that. So anything that's never been recorded before in the UK gets excluded. Now that can obviously exclude very rare or emerging species, but and there are other filters you can apply at the start of the process to try and clean up the sound files. We've got an MSc student working with us on that to try and to see if we can improve the sound quality to get a higher hit rate on the detections.
Yeah, there's a question on the back of this, and I suppose you've sort of half answered it. Are you using BirdNet for this? If so, how do you counter errors, like i.e. such as red wings during the summer months and things like that? How, I mean, you mentioned do you use that time and date information as well? Yeah,
that example I use, like eBird, for example. If we were to use that filter, then it's unlikely it's not impossible, of course, but anyone would have reported a red wing in the summer, because they're typically not present. So there'd be a very, very low likelihood of occurrence. We do get false positives. Anyone who's used Merlin would probably find that from time to time they get some weird thing popping up, and it seems true of what we do. However, we start to look at the data. You've got a data set of 1 million records, and you get 1 or 3 records of a pretty unusual bird. These things can be almost excluded just by looking at the data. You can go back and hear the call, but you can look at it and go, hang on, if it's a nightingale would sing continuously for days if it was on site. And you've got 1 record of a nightingale. I can almost assure you it's wrong. But that's 1 record out of 1 million data points. So, you can go back and validate and exclude these from the data set. It's inevitable you'll get some. We get some weird things. I think I mentioned, Paul, I can't remember if I told you this. There's someone played me a recording, and it sounded like a nightjar. Yeah, it sounds like, and the guy said, actually, no, it was a mole cricket. So, we've had cases of, a bird called a corncrake. It was actually rain hitting an electricity pylon right next to the recorder. So you get this weird stuff, but it's pretty. It's such a small occurrence. If you exclude all these things, you're still left with 99% of the at least of the data. And again, think about the data being different. It's not just, species lists are important, but equally changes over time. We think someone described this, what we're doing is a difference between taking a photograph and watching a video. Site survey is a photograph, but we're making videos here, if you like. It doesn't have to be perfect, but you are getting, it may not be perfect, it may not be accurate, but it's consistently inaccurate.
Yeah, but who's the person that can sort of, because I know you're a very knowledgeable birder, and you can say that you don't get corncrakes on in the where I live, for instance, in the middle of the Peak District, but you're doing a part of the world that you're maybe not familiar with. Is it, do you rely on you punt that back to the client and say, here's some things we've got very few calls off, you might want to look at that? Is that how you kind of interpret that?
Exactly. So we this project I mentioned in the talk, we're working in the Peruvian Amazon with a PhD student, and this is the first thing we almost did as a trial from outside the UK. And she sent us 4 months of audio from 4 recorders, and we processed them, sent her the data back, and she wasn't skilled enough to understand each tag of each species. But there's a local guy, Chris Kitola, on the ground, and he really knows his stuff, and he went through and validated the records. And as I thought, some species that we didn't have a model for, others are just so hard to tell apart. Some of the parrot species, for example. But he did find a little nightjar, which he was very happy with the results. And, that was 100 kilometers from anywhere it had been recorded before. But it's a cryptic nighttime species.
There's someone's asking a question. It was kind of in the chat, really, but I've dragged it over into here. And they're questioning why you're looking for a species every 3 seconds. So if you consider a positive record every 3 seconds record a bird is heard, does it overestimate the abundance of the species? Now, I notice you sort of answered that question a little bit to say, actually, coming up with abundance of species is very difficult. Because is it one bird calling 100 times or 100 birds calling once?
Really?
But how do you deal with that data? Why wouldn't you use a longer duration, like 60 seconds or something like that? Is there a specific reason for that?
Well, what we do is if you think about a bird sonogram, the calls are quite short. So we're trying just to catch that sonogram and analyze that pattern. Because all we're looking for is patterns at the end of the day. It's just a pattern of a wave pattern. So 3 seconds is there's been some work done on this, a few papers on it. So 3 seconds is is a bit of a compromise. We could make it 5 seconds or whatever, and we've tried different sampling frequencies. But we're just trying to get a richer source of data. I mean, it takes us to process an hour-long file. It takes us about 30 seconds, and we can process a number in parallel. So I know in the past there's been some concerns about sample the data to 2 minutes per hour or whatever, just because of the volume of data and the processing. Well, that constraint's really gone away now. I mean, transferring data is still a challenge. We have customers who post us their cards to us or whatever. That's still the case. In fact, we've got a project off an island off Australia where they've got Starlink as the only way of getting data, and it had 30 gig of audio. I think it'd be quicker for them to post it to me in the UK from Australia than to upload the data.
It's an interesting question. Have you found that installing the recorders in a specific way results in better quality recordings for these long-term projects, or does it just depend on site conditions?
I think it's really hard to unpick that, to be honest, because we try and take a standardized approach, but each site's slightly different. Again, I think it comes back to what's the purpose of the survey. Is it species richness, how it changes over time, or just species lists or particular indices you're looking at, wading bird indexes? So as long as we're picking up the species on a fairly regular basis, then it doesn't matter too much. We're trying to come up with a really good solution, not a perfect solution. This is not going to capture everything.
Yeah, I kind of like that it's not the be all and end all. I mean, on that, it's probably the last question because we're running out of time. But what change indices do you recommend? Like, start with a species richness and a diversity index. Are there any other recommendations that you'd put in?
Well, actually, it depends locally what it is. I mean, in the UK, we have things like the Farmland Bird Index, or a Wading Bird Index, or a Lowland Peat Index, or a Raptor Index. Again, or a site-specific index. You know, we have sites where they're tracking perhaps 10 red listed or endangered birds, and that's what they're tracking as a key indicator for that location. These things are really easy to set up. I mean, it'll take literally 5 minutes to do it, because we've got this big data lake underneath. All it is just creating a subset or a view onto that data. You know, we're starting to explore. I mean, for example, you know, we don't do bats yet, but something as you know, we're looking at. But you know, if you can identify, for example, just the feeding buzzers, then you can start to understand how bats are perhaps using a site more as the site changes, if it's going through some sort of regenerative agriculture process. So I think there's lots of creative ways we can think about how to use this data. Now we're getting so much data. We can ask. I mentioned this thing. We can ask such different questions. We're finding new behaviours of birds that hadn't been reported before in the UK. Chetty's warbler at 3 a.m. in April and May going nuts, 20 times the background rate. And in fact, someone told me the other day, this isn't a known thing. They used to do work in Spain, and the Chetty's warbler, its common name is the bastard nightingale. Because it just makes such a racket before dawn, like a nightingale does. But it's not.